Hello friends, welcome to Code Sutra. In this video I will be explaining about LeetCode problem number 35, search insert position. In this problem you are given an array and you are given an element. You have to find out if this element is present in this particular array and return the index. If the element is not found, you have to return the index where the element has to be inserted. Okay, so what is the first idea that comes to your mind? Suppose this is the array and you have to find out 10. We can do a linear search, that is, we can search 1, it's not equal to 10, 3 not equal to 10, 5, and similarly we go on until 10, and if we have found the element, we will return the element. Okay, so what is the ideal way to approach at this problem? Before diving into this solution, see, I can directly dive into the solution, but the idea is to explain what is binary search step by step, so that whenever you see any problem that is related to binary search, you yourself should be able to arrive at this particular approach. So what is binary search? See, first of all, if you are given this array and you are asked to find out 0, will you even start? No, right? Because 0 can never be found in this array because the first element is itself 1. Similarly, if you are asked to find out 15 in this array, will you try to do this? No, right? Because the ending element of this array is itself 11. So can you find out 15? No, right? So that is the core idea of binary search. That is, you have a search space. In this particular example, the search space is between 1 and 11. Only if the element is between these values, then only you will start the search. If not, there is no point in starting the search. The first idea is there is a defined search space and the arrays have to be sorted, or the search space that we are going to operate has to be in the order. That is, either it is in the ascending order, descending order, or some order has to be there. That is the first idea. What is the second idea? Say you are trying to find out 10 in this particular example. You pick up a random element, right? You pick up 5 in this case. And what is the element that we have to find? 10. Whatever we did in the previous step, can we do it here also? See, let's split the array into two parts. One part is this and the second part is this. So where do you think 10 will be? Can it ever be on the left side? No, right? Why? Because 5 is itself lesser than 10. So if it is not found at this point, what is the point in searching the left space? So what we will do, we can easily eliminate the search space, half of the search space. In this case, I picked up a random element, so we can eliminate all the values left to it. So why do we have to pick up a random element, or should we pick up the middle element? For example, in this, how many elements are there? 1, 2, 3, 4, 5, 6, 7, 8. So should we pick up the middle element, this or this, or can we just pick up any random value? What is the core idea? The core idea is you have to pick up the middle value. Why you have to pick up the middle value? Say for example, you picked up this value and you eliminated this value. What is the advantage? Right? You just eliminated just 1 in the entire array of length 8. So that is not the idea, right? I mean, you might be lucky and you can eliminate this half, but in computer science, that is not what we do. So to be on the safer side, we will pick up the middle element and we will eliminate the search spaces. Okay, let me dry run this problem. See, the first thing that we will do is we will have two variables, low and high. That is the range. What is the range? The element can either be at the 0th index or it can be at the end index. So that will be our low and high. So what will be the mid? The mid will be just be equal to low plus high by 2. So I have given here 0, 7, and what will be our mid value? In this case, our mid value will be 3. So we will go at 6 and we will try to find out 10. Is it equal to 10? No, right? So what is it equal to? It is equal to 6. So can we eliminate other half of the search space? Yes, right. So this is what we will be eliminating. So this half of the search space, it can easily be eliminated. So what do we do in this case? We will just change low to mid plus 1, that is 4. If at all we find the element, it will be in the second half of the array. So now we recalculate the middle value. What will be the middle value? 7 plus 4, 11, and it will be 5. So this was 3, 4 and 5. We go to 9 and we check if this is equal to the element. It is not. So again we eliminate these two values also. So what will be our new mid? our new mid will be our new low will be 6 and our high will be 7, and our mid is equal to 7 plus 6 by 2. What is 7 plus 6 by 2? That is equal to 6. We go at this particular value, and here we have found the element, and that will be our answer. Our answer in this case will also be equal to 6. Okay, this is when we find the element. So what if we don't have the element? Say for example, in this particular example, what if this was 11 and what if this was 12? So what is the point? What will happen? Let's look. All the same thing will happen, but when you come here, right? When you come here, what will be the middle value? It will be 6, it will be 7, the middle will be 6, but you found out 11. So you can easily, similarly eliminate the other half of the search space. So once you have eliminated this, the entire search space is eliminated, or your mid and the low value becomes equal. So that is what is happening. So, but if you look here, your mid value is still equal to 6, right? So that will still be your answer, even if there is no answer in the given particular array. Okay, let me take you through the code. Yeah, please do like and subscribe the video if you are enjoying the content of this channel. What are we doing here? We are initiating the low variable to 0. That is, we are defining the search space, that is to 0, and high, that is the length of the array minus 1. So what we do, we create a while loop and we calculate the mid at every step. That will just be the middle element. And we try to find out if the target equal to middle, we will just return it. If not, if the middle element is greater, we just reduce the search space. That is, we eliminate half of the search space. Similarly, the lower half of the search space, and at the end we just return low. See, if we are finding, we are returning the mid here. If we are not finding, we are returning whatever the position that we stopped, whatever is the low position that we stopped, we will return there. Thank you for watching the video. Please do like, share and subscribe.